In contemporary physics, two of the most influential theoretical frameworks are the quantum field theory and the string theory. Both theories are attempts to unify the physical principles, but their methods and scopes are very different from one another. The contrasts between quantum field theory and string theory are going to be discussed in depth throughout this essay. The theory of quantum fields. The quantum field theory, abbreviated as QFT, is a theoretical framework that was developed to describe the behavior of particles and fields on the quantum level. It is a means to quantify the probability of various outcomes for a certain experiment, and it is founded on the concepts of quantum mechanics as well as special relativity. Particles are modeled as excitations of quantum fields in quantum field theory, QFT. These fields pervade all of space and time, and their interactions with one another produce the forces and particles that we see in the cosmos. Both space and time are permeated by these fields. The standard model of particle physics, which is our current best description of the fundamental particles and forces in the universe, uses QFT to describe the behavior of particles and fields. QFT is an example of a quantum field theory. The usage of Feynman diagrams, which are graphical representations of the computations that are used to forecast the outcomes of experiments, is one of the most important aspects of quantum field theory, QFT. These diagrams are an essential tool for determining the odds of a variety of events because they illustrate the interactions that take place between particles and fields. The theory of strings. The theoretical framework known as string theory makes an effort to incorporate all of the many forces and particles that are present in the universe into a solitary, consistent theory. It is predicated on the theory that the fundamental building blocks of the universe are not particles but rather incredibly thin strings that only exist in one dimension. According to the string theory, these strings vibrate at a variety of frequencies, which results in the existence of a wide variety of particles and forces that we can perceive in the universe. Beyond the three spatial dimensions and the one temporal dimension that we encounter in our day-to-day lives, the theory postulates the existence of other dimensions that we do not experience directly. The concept of supersymmetry is one of the most important aspects of string theory. This aspect argues that every elementary particle has a superpartner that possesses the opposite quantum properties. This symmetry could be able to assist explain why the forces in the universe are so precisely calibrated to allow for the existence of life. Contradictions between quantum field theory and string theory. The primary distinction between QFT and string theory is their respective domains of application. In the standard model of particle physics, the quantum field theory, QFT, is a well-established framework that is utilized to describe the behavior of both particles and fields. Its applicability is restricted to the particles and forces that are already known to exist in the universe. String theory, on the other hand, is a more ambitious framework that aims to unite all of the many forces and particles that may be found in the universe into a single, consistent theory. It predicts the behavior of particles at energies far beyond what we are currently able to see and suggests that there may be extra dimensions outside the ones we are familiar with. The way in which they approach things is another significant distinction. The quantum field theory, QFT, is an approach to calculating the probabilities of various outcomes for a certain experiment. It is founded on the concepts of quantum mechanics and special relativity and provides this method. On the other hand, string theory is a theory that is more open to speculation and is still in the process of being created. It is not yet clear how to put the predictions of string theory to the test, and further investigation into this topic is still ongoing. In conclusion, despite the fact that both quantum field theory and string theory are attempts to unify the physical laws, they are distinct from one another in their methodology and their areas of application. While QFT is a well-established framework that describes the behavior of particles and fields in the standard model of particle physics, string theory is a more ambitious framework that seeks to unify all of the forces and particles in the universe into a single, coherent theory. QFT is a framework that describes the behavior of particles and fields in the standard model of particle physics.